Good morning. In a previous class, we were already covered the stability of suspension, stability system of the suspension. But this polydispersibility or redispersibility was there. Have not covered this thing. So redispersibility, it is an important parameters of a suspension because every pharmaceutical suspension must be redispersible by mechanical shaking. Above mentioned parameters evaluate the sedimentation behavior. Evaluation of redispersibility of a sediment is also important as per the definition of physical stability. A mechanical shaker device which stimulates the human arm motion that can be used to achieve reproducible result under control conditions. Such method acts as a rough indicator for the rapid screening of suspensions for their stability. Various modifications of the basic principle have been available in the literature. For example, the suspension may be placed in a 100 ml graduated cylinder and after storage and sedimentation, the cylinder is rotated through 360 degree at 20 rpm. The end point is taken when the base of the cylinder is clear of sediment including the uniformity of suspended drug particles. The time required for a time required or number of revolution are noted. The shorter the time or lower the number of revolution, the greater or faster the redispersibility. So range of particle size might have an influence on the tendency toward caking. When the drug material is in the dispersed state, the dispersed material will have an equilibrium solubility that varies relative to its particle size. Small particle will have higher equilibrium solubility than the larger particles. So, these small particles will have a finite tendency to solubilize, subsequently precipitate on the surface of the larger particles. Consider the fluctuations in temperatures. Thus, the larger particle grows at the expense of the smaller particles. This phenomenon is known as Ostwald ripening. So our stability of suspension is almost over and comes to this point, drug release and resolution study of suspension. This is the principles of drug release, the diffusion control dissolution. The dissolution of suspension categorized into two ways. One is a dissolution profile for monodispersed system and next is dissolution profile for polydispersed system. The basic diffusion control model for suspended particle was developed by Noyes and Whitney and was later modified by Nernst equation. The equation is like that, the dq divided by dt equals to d into a into cs minus cv divided by h, where dq divided by dt is represented as a dissolution rate, h where h is the diffusion layer thickness, that means the thickness or height can be measured by centimeter or millimeter like that as an unit. Next, cs is the solubility and cb the bulk area of the particle. This model represents the rapid equilibrium at the solid liquid interface that produces a saturated solution which diffuses into the bulk solution across a thin diffusion layer. Now comes to the formulation of suspension. I have already uh, told this thing, the flow chart of formulation of suspension. The formulation of a suspension depends on whether the desired suspension is flocculated or deflocculated. That means so whether we are formulating a flocculated suspension or we are formulating a deflocculated suspension. So two approaches are commonly used here. One approach involves the use of structured vehicles to keep particles in a deflocculated state. If we are preparing deflocculated system or deflocculated suspension, then this approach may be applied, uh, which is involves to the saturated structured vehicles. And the second approach keeps the particles in a flocculated state in order to prevent cake formation. The third method uses a combination of earlier approaches to prevent the settling. The different schemes are illustrated in this figure. This method are discussed in detail and subsequent sections like here. This should be and the particles, finely divided particles. The addition of weighting agents and dispersion medium. The particles are added to the dispersion medium. Weighting agents is added. So this things is a mixture of finely divided particles plus weighting agents plus the dispersion medium or the continuous phase. Fine. So resultant is what? The deflocculated suspension or deflocculated particles or suspension like that. But it is not the final state. If we added the saturated vehicles, so addition of saturated vehicles, we will get the final thing, the deflocculated suspension. Okay, the deflocculated suspension in a structural vehicle as a final product. So it is final product of deflocculated suspension. So comes to these things, deflocculated suspensions, but not this is please remind that please note that this is not the final stage of suspension. Okay, if we adding the the structured vehicles to this structured vehicle to this, then we will get the final product. And if we adding the flocculating agents, then we will get the flocculated suspension as final product. But the addition of flocculating agents, we will get the flocculated suspension. Then addition of structured vehicles into this flocculated suspension in structured vehicles as final product we will get. So is this thing is clear to all? The formulation of suspension, how we formulate the suspension. First, the dispersion of solids. Dispersion process involves the intimate contact of solids with water as a vehicle. This is a critical and difficult step because most solids are hydrophobic and in nature. That means water hating in nature. In addition, when finely divided powders are selected for a reason of a better physical stability, they absorb or entrap a lot of air, which is difficult to expel. So, as a result, solids float on the surface of the vehicles. Though their densities are high, weighting ability of a vehicle is ascertained easily by observing the contact angle that the powder makes with the surface of the liquid. Water miscible co-solvents such as alcohol, glycerin, propylene glycol are commonly used to disperse the hydrochlorides. The process of weighting by glycerin is summarized. During mixing, glycerin forms a coat around the particles and completely separate them. Since water is miscible with the glycerin, it can immediately surround the particles and weight them. This process is used as an initial step to disperse the particles. At this state, the particles are deflocculated in the vehicle. Now comes to the surfactants. Surfactants aid in dispersion by reducing the interfacial tension between the solid particles and the vehicle. As a result, the contact angle is lowered and the air is displaced from the surface of the solids. Surfactants in the HLV range of 7 to 9 are used as wetting agents. A minimum amount of surfactant is used because they produce foam and create problems during mixing a later stage. So we have to use the minimum amount of surfactants.